Now, these are all the transformations that we have done with our matrices. Can you give me one? Reflection. Yes. Rotation. Transformation.
Translation.
Translation. Yes.
Enlargement.
And enlargement. Now, whenever we do this, something changes. There's always a change. That's the purpose of transformation. The change might be a reflection, the change might be a rotation, the change might be a movement, or the change might be bigger or smaller, or even inverting it for negative enlargement. Okay? This is using our XY coordinates like you did in the last two classes, if I'm not mistaken. What we want to look at is there are some 2x2 matrices that are responsible for these transformations on our XY plane. The first thing we want to try to do today is, what are these matrices? Which of them is responsible for which one? How are we sure they are responsible for this transformation on our XY plane? And if a question in IGCSE is asking you to write down the matrix responsible, what matrix do you write down? These are all IGCSE papers. But then, we need to see the preamble first. I'll start with the reflection. If you have the XY plane, we'll be putting the summary here. If we start with the XY plane, let's say we have a triangle. Or let me use a square to make it easy. Let me use a square. What is the coordinate of, let's call this point A, point B, and point C and D. Let's say a square of length 1, for example. Okay? This point will be x is 1, y is 0. Agree? Is it? This point will be what? 1, 1. And this point will be 0, 1. And this will be 0, 0. Okay. Let's see what happens if we reflect along x-axis. Candy? Tired? Sorry. If you reflect along x-axis, this point will be here. Agree? This will change to what? 1, negative 1. Agree? Yeah. This point will change to 0, negative 1. Every other thing remains the same. Then this will be your B prime, and this will be your what? A prime. Okay? So this is the reflection. Now, instead of drawing this, we can actually just multiply by a certain 2x2 matrix, and we'll get this result. So now, initially, we have our B, this and this to change, right? Only two of them are changing. Do you agree? We have our A and B changing. Okay, so let's see. If we multiply by this point, let me begin with A. The point x is 0, y is 1. If you multiply it by the identity matrix, let's see what happens. What do you think will happen if you multiply it by the identity matrix? Say that again. Why did you say that?
The identity matrix should make the numbers down.
Did you hear what he's saying? Does anybody hear what he said?
Yeah.
You don't even need to multiply. Because being an identity matrix, remember this principle? AI equals IA equals what? Plus A. Identity matrix does not change it. It enables it to retain its identity. So if you multiply this, you must get this back. So what do I mean by that? 1, 1, we get your 1 times 0 plus 1 times 1, right? Another 1, 1. Oh, Our identity matrix is 1, 0, 0, 1, sorry. Okay, so this is 1, 0. Am I right?
That's right.
1, 0. So is that not 0?
Yeah. It is. 1 times 0, 0, 0 times 1.
Okay, so that's 0. And the other one, what would that be?
0, 1.
1.
0 plus 1.
So it doesn't change when you multiply by the identity matrix. So if the matrix, if you are looking for a matrix that does not change the transformation, you just go to your identity matrix. So let that be our summary number 1. I equals 1, 0, 0, 1. What does it do? No transformation. Okay? Now, if I want to get this point, I want to make it 1 minus 1. Let's see what matrix we multiply with. I want to transform this to 0 minus 1. Okay? What matrix are we dealing with here? Let that be A, B, C, D. For example, we want to figure out what matrix does the reflection. Am I making sense, anybody?
Yeah.
What matrix will reflect this today? This is reflection from our sketch. Now, multiply. What do we have on this side? A times 0, B times 1. Right? What is that? B. Then C times 0, D times 1. What is that? D. So only what? B is equal to 0, D is equal to -1. It means what happens to A and C? Nothing. It doesn't matter. A 0, preferably. So we can call the matrix 0, what's B? 0, what is D? Wait.
No, it's
Yeah.
Yes. 0, -1. If that is nothing, it doesn't mean it does not exist. It's just that it doesn't make any difference. Do you agree with me? It just means it doesn't make any difference. How about we take that to be 1? Let's see. Because 1, of course, doesn't change anything anyways. But that's going to be a 0 after all. So let's see. We're going to try the same with B and see what happens. Let's see, this matrix with 1, 1 gives us the reflection we need. What reflection is that? 1, -1. Let's see. Multiply, what do you get? 1. Multiply this, what do you get? 0. Then that's not what we want. How about I do this? I think it's because of the point that I'm using. Let's pick an arbitrary point. I do not want to write the matrices. I want us to figure it out first. Then I can write the summary for you. Let's pick a random point, say AB. What will be the reflection of this AB on this side? Again? A, -B. All right, so let's use this. We want to reflect point AB to give us A, -B. Our matrices, W, X, Y, Z. Let's figure out what matrix will do the job. Okay, I think this would be a better option for us. Okay, let's see. What is this? WA plus XB equals A. Agree?
Yes.
Then the YA plus ZB equals -B. Is there a way we could work out our W, X, Y, Z from this? Is there a way? WA minus A will be minus XB, right? AW minus 1, -X. This is getting more complicated than I thought. Or
So WA minus
this is getting more complicated than I thought. This wasn't what I was looking for. I used a simpler way last year, so maybe I use that. If I'm reflecting matrix 1, 1, 1, 0, 1, 0, if I reflect this point 1, 1, I get the point what? X is 1, y negative 1. So this point changes. The y aspect changes, not the x aspect. Right? For this part, what changes here? Also the x. So if I reflect along the x-axis, the y changes but not the x. Okay, let's see. If we reflect along the y-axis, this same point, along the y-axis is going to be here. Do you agree? So if this is 1, 1, what will the reflection look like? Negative 1, 1. And so this is the original shape. So the reflected shape will look like this. So this point also has changed because this and this does not change, do not change, right? So this that used to be, what is x, 1, y is 0, changes to what? Negative 1, 0. So now, for reflection along y-axis, and this is for reflection along x-axis, okay? So there are two different matrices that are responsible for this reflection. One of them, let's see, we agreed 1, 0, 0, 1 doesn't make any change. Okay, let's see what happens if this is 0, 1, 0, 0, 1, 1, 0. Yeah. Multiply this by any point, maybe 1, 1. Let's see. Multiply. What is this? Anybody? 1, 1 again?
Wait.
Is it?
Yeah.
So let's see, which one is that? 1, 1 changing to 1, 1. Okay, none of this. This is 1, negative 1, okay? What happens with this?
1 negative 1.
1, negative 1? Is it 1, negative 1?
Yes.
So this is responsible for this transformation. Let's test it with this point. What point is this again?
0, 1.
0, 1. Okay, so if you test it with 0, 1, what do we have? The reflection of 0, 1 is what? 0, negative 1. So multiply, what do you have? Is everybody part of this? If you multiply that, what point do you get?
1.
Multiply this.
1, 0.
1, 0. Okay, so the first one is 1, and this is 0. So that is not. So what transformation is this that puts this point to 1, 0? Where is 1, 0? When x is 1, y is 0 here. So what transformation is that? Actually, this is another transformation we have just gotten. What's that?
Diagonal.
Diagonal? Did you see that? Hello?
Yes.
Can you see that? This matrix changes this to this. So what kind of transformation is that? No, there's nothing like transformation diagonal here.
Oh,
Reflection along along the x, no? Y equals x. That's it. I think it's a bit confusing to some of you. No?
Kind of confusing.
Kind of confusing. Yeah, it's because of the way I was putting it. This is still all reflection. This is still all reflection. So this first matrix, what did we agree that this one does again? If you do this, what do you get? 1. This is 1. And what about this one? 0. Is it? Is it 0? So if you look at that, so on the x-axis, you have point, when x is 0, what is that again? When x is 0, y is 1 here. Then the reflection is here. Can you see that? So this is a transformation along y is, a reflection along y is equal to x. Did you see that?
Yes.
So let's see how we can get for this one. the reflection along y equals negative x. Can anybody think of what we can do to change our 1, 0 to this point? What is this point going to be? Negative 1, 0. So, how do we get negative 1, 0? Let's see. We want to change 0, 1 to negative 1, 0.
0, negative 1.
0, negative 1.
0.
No.
Oh, 1, 0.
1, 0. Let's check that. Do we have it?
No, I think that should be also.
No, you should
Yeah.
check. Yes. 0, negative 1. 0 again, 0 again.
Yeah, negative 1 is okay. If you say 0, negative 1, negative 1, 0 also works.
You mean 0?
Negative 1, negative 1, 0, it also works.
It's also, okay, let's see.
Because
It's
it's
just the-
It's
just the
negative,
left
it's just-
side.
No, it's working because of this.
Yeah.
But what if it's not?
as soon as
Do you understand my point? Because now, let's see. This is usually this and this. I want to pick an arbitrary point. If you have a 2, for example, the reflection should come here. Okay? So then let's just check too many things. Okay, so this one works for that. What happens if you have this and this on any point? Let's see. Let's see what happens to a point 1, 1. What do we have? Anybody?
1, negative 1.
1, negative 1. Okay, so what does that tell you?
That it is right.
Hello?
1, negative 1.
Do you agree this is 1, negative 1?
Yeah.
So where is 1, negative 1? This is 1, 1. No, this is 1, 1.
Down.
So where is 1, negative 1?
where the
1x is 1, y is negative 1. So what's that?
Reflection.
Reflection by
Along
The x-axis.
x-axis. So this is the x-axis along reflection. This is the y equals negative x. This is y equals x. Okay? So again, let's change something else. What is there again to change? What if both of them are negative 1? What do we have?
Negative 1, negative 1.
Negative 1, negative 1? Okay, so let's see what that does. It's from 1, 1
That's the
to negative 1, negative 1.
y to the negative x.
Oh, are you sure?
Yeah.
I thought that was this one.
Maybe they both work. Wait,
No,
wait.
both of them can
Wait,
both of them.
no, that's the opposite of 1, 1. The opposite of 1, 1 is 1.
Are you sure this is negative 1, negative 1?
Yeah.
Check please everybody.
Yes.
0, negative 1, minus 1, 0, yes.
The opposite of 1,
So,
1.
okay, again, 0, minus 1, yes. Minus 1, 0 on, let's pick another random
0,
point
1.
and see. 1, 0, what do we have?
Oh,
0,
negative
negative
1.
1. 0, negative 1.
0,
Negative 1.
like this?
Yeah.
Okay, so where is this point? 1,
0.
0.
Yes.
1, 0 is here.
Reflection from the
What
y.
is 0, negative
At
1?
the bottom,
Here.
Oh.
So this is the one.
y equals x.
So this is an error,
yeah, we can see
definitely.
it.
So this is the one. So this is your y equals negative x.
Good, I think so.
So let's compare y equals x and y equals negative x. What do you see?
There.
Do you observe something?
They're both positive or both negative.
They are both, one is what?
One is both positive, one is both negative.
What kind of matrix is this? Well, it's not a diagonal because it's not.
What's it called?
It is leading diagonal anyway.
Transposed identity.
It looks like identity, but they change the where 1 and 0 should be, isn't it? So if we have 0, 1 and 1, 0, what does this do? Reflects along what? Y equals x. But if you change it to this, what does that do? Reflects along y equals negative x. Can you see that? Anika?
Is it adjoint the other?
I know we had a rough start.
Yes.
I know we had a rough start. The thing is, I didn't just want to write the whole summary. I want you to see what that summary really looked like in the picture. So that's why maybe I should have thought of a better way to present it at first. Anyway, so let's see how we can get, so if you do not reflect this way, you do not reflect this way, there are two other ways we can reflect. What other ways are those? X-axis and Y-axis. Okay, so let's see. Let's pick, sketch this again. Please, I need your contribution and maybe some decorum. So this point, 1, 1, when reflected along x-axis, must give us 1, negative 1. Okay, so let's see. 1, 1, we are trying to get 1, negative 1. The matrix is always just an adjustment of the identity matrix with different permutations of 1, 0, and 0 minus 1. That's like a summary I can give you. Okay? So how can we permute the elements?
0, 0, 1.
1, 0.
0, 1.
Negative 1.
Come on, Javi, this will be no transformation.
Negative 1.
Okay, so let's see. Is this what you have?
1, negative 1. Yeah.
Yeah.
Are you sure?
Yeah.
Yes.
0.
Okay, so let's pick another random point. Maybe the point here. The point here will be what? When x is negative 1, y is 1. Okay? And the reflection will be what?
Negative 1, negative 1.
Negative 1, negative 1. Giselle, are you part of this? Or just in your home world? The reason I'm doing this computation is that questions will be given to you and say, you already know the reflection, the transform, maybe something like this. Describe the transformation from A to B. You know the transformation is along x-axis. The next question will be write down the matrix of the transformation. That's why we need to go through this together. So you don't have to memorize different matrices for different transformation. Do you understand what I mean now?
No.
No? You don't get it? So there's a picture, maybe in your, there's a picture, something like this. And this was given. Okay? The question will be, describe the transformation that maps A to B. What will be your result?
Triangle A.
Reflection.
Triangle A reflected in the x-axis to form triangle, to give triangle B.
Can I say y equals to 0?
What?
Can I say y equals to 0?
Y equals 0, yes, of course. Along y is equal to 0 to give you that, right? So the next question will be, right, what matrix is responsible for your transformation? Do you understand? So that's why I'm going through this calculation so you know. The first thing is, everything looks like this, but arranged in different forms. With minus 1 plus 1 written in different ways. That is the summary of the whole thing. Okay? Now, so do we all agree this will give us that? So let's see, 1, 0, 0 minus 1 with the second point. Let's test with the second point. What do we have?
Negative 1.
Negative 1. Agree?
Yeah.
So can you see the same matrix transform this to be this?
Yeah.
So which means this matrix 1, 0, 0 minus 1 does what? Reflects
Along the x-axis.
along x-axis. So I think without doing any computation, you can always get the one that reflects along y-axis.
Negative 1, 0, 0.
Negative 1, 0, 0, 1.
Flex along y-axis.
Now, does anybody notice any pattern?
It's opposite for the, like the,
Transpose, you mean? Let's see. You mean transpose and adjoint? So which one is the adjoint of which one? What? Who is they? There are 5 matrices on the board.
Y equals X is an adjoint of Y equals X.
Okay, is it right?
yeah.
Yes. These are adjoint of each other. Are these also adjoint?
Yeah.
Because you switched them.
Are these also adjoint?
Yeah.
No.
Yes. Because if you negate this 0, it's still 0. So that's a good way to remember. So these are adjoint of each other, these are adjoint of each other. Then this is just, you flip Can you see that? You flip the identity matrix. Okay? When you negate it, you get this one. Does it make sense? So you just need to remember from identity matrix, you have different arrangement. Flipping it is a reflection along the x-axis. Negating that is a reflection, along y is equal to x, along y is equal to minus x. Then when you change, when you have minus 1 here or when you have minus 1 here, you have the reflection along the x and y axis separately. Does it make sense now? So these are 5 different reflection matrices. Okay? The next simple ones we can look at, I'll go to this enlargement. That's so easy. This will not be discussed because it's a vector. Translation is by vector. You've been doing that. Something like this, x, y. You know what this does.
Yeah.
So we are only concerned about 1, 2, 3. Does it make sense? So please, these are 5 matrices if you want to take notes. Particularly how we did the calculation. But I have the summary, so maybe you shouldn't. I have the summary here, so please don't. I have the summary here. It's just that for my reflection here, I have 4. Of course, the only reason I put this one is for us to see that identity matrix does not do anything to the shape. Does it make sense?
Yes.
So, but these 4 are here. I think there was a typo error when I print. Can you check this? Compare them and see if there's any typo somewhere. But I think somebody raised a typo, whatever, sometimes last year.
This from us.
I give them this summary also, but we did the calculation in class. Is it the same?
Yeah.
Summary is the same?
Yeah.
X-axis, y-axis. Yeah, I think it's the same. I think it's the same. Okay, great. Then we don't have to worry. Or maybe the typo was
So
on.
rewrite that?
No, because I'm going to give you this to stick in your notes.
That's why I said you were not here. You were thinking about whatever.
You said why always make your life.
Yeah, okay.
Last time I tried this filming.
Okay, so for enlargement, look at this, everybody. If I have Candy, if I have this, let's pick any random point, say A, and the y-axis is B, then what is this coordinate? AB, right? Come on, everybody.
Yeah.
So what is this coordinate in full?
A, 0.
And this is
0B.
0B. Okay. If you enlarge this shape using a scale factor of 2, okay, and the center of enlargement is 0, what would this image look like? Describe. So from 0, what's this? The enlargement of this point going to be? Okay, let's change it to 3 so it doesn't look too obvious. Yes? 3B, somewhere here. Agree?
Yeah.
So what about this one? We have 3A. Are you following everybody?
Yeah.
Then this point, of course, will be 3A, 3B. So the enlarged shape would look like this. Are we getting that?
Yeah.
So this point, A, B, change to what?
3A, 3B.
3A, 3B. Do you see that? So what matrix do you think is responsible for that?
0,
3, 0.
0.
Are you sure?
Let me check. Yes. No. Yes.
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 Yes. Yes. I just have to be sure.
Oh.
Do you agree this is actually?
Yeah.
Yes.
That's right.
Oh, yeah.
First, identity matrix does not reflect, doesn't do anything. Multiplying by 3 is just to make it bigger. Does it make sense now? So for your enlargement, for scale factor enlargement,